Welcome to the lecture series on Laplace transformation. Today we are going to solve a differential equation using Laplace transformation method. So first we should know the Laplace transformation of a derivative to solve a differential equation. So if you consider the first order derivative, the formula will be written as s into f of t minus f of 0, and Laplace of f double dash of t is equal to s square L of f of t minus s into f of 0 minus f dash of 0. And if you apply for third order derivative, L of triple dash of t is equal to s cube L of f of t minus s square of f of 0 minus s into f dash of 0 minus f double dash of 0. So like this it will continue for the higher order derivative. Now I am going to use this method for solving a differential equation. So let us see the first problem based on this. So this time I have taken the first problem as solve y triple dash plus 2y double dash minus y dash minus 2y is equal to 0 based on the conditions y of 0 is equal to 0, y dash of 0 is equal to 0, y double dash of 0 is equal to 6. Okay, so these three are very important. We are going to use this in the middle of the problem. Okay, now here I am going to use some terminology here. What are those means? L of f of t. Instead of using this term, I am going to use y bar of s, because I am considering it as y is equal to f of x or f of t. So instead of using the terminology f of t, I am going to use this term instead of applying Laplace. Okay, so making this as note, I am going to continue with the problem. Okay, so given y triple dash of t plus 2 into y double dash of t minus y dash of t minus 2 into y of t they have given is equal to 0. This is the given differential equation based on the initial value conditions, that is y of 0 is equal to 0, y dash of 0 is equal to 0, and y double dash of 0 is equal to 6. Okay, now I am going to apply Laplace transformation on both sides. L of y triple dash of t plus 2 into L of y double dash of t minus L of y dash of t minus 2 into L of y of t is equal to 0. As we have seen above, we are going to apply the Laplace transform for each term. So here for the first term we are having third order derivative. I am going to apply the formula for third order derivative. Okay, so it will start like this: s cube y bar of s, instead of L of f of t I am going to write y bar of s, minus s square y of 0 minus s into y dash of 0 minus y double dash of 0. So this is the formula for the first term, plus 2 into, I am going to apply the formula for the second term, that means second order derivative. So it should start with y square y bar of s minus s into y of 0 minus y dash of 0. Next for the third term, minus, it should start with s into y bar of s minus y of 0 minus 2 into L of y of t can be written as y bar of s is equal to 0. So in this way we will apply the formula. Okay, now I am going to take y bar of s is common in each and every term. Here is there. So we have total 4 terms containing y bar of s. So s cube plus 2s square minus s minus 2 into y bar of s is there. Okay, next In all the remaining terms, if you observe, this term it becomes 0, this term becomes 0, this term becomes 0, this term becomes 0, this term becomes 0. Okay, why? Because here they have given the condition that when y of 0 is equal to 0, y dash of 0 is equal to 0. So all these terms will become 0, only this term will remain same. This term will remain same. So I am going to write that term. So minus y double dash of 0 is equal to 0, because y double dash of 0 is equal to 6 we have. So I am going to substitute that value. Okay, s cube plus 2s square minus s minus 2 into y bar of s minus this value is 6 is equal to 0, which implies I want to find y bar of s here, which is equal to 6 divided by s cube plus 2s square minus s minus 2. So this is the value which we got. Now take this as equation 1. Consider 6 divided by s cube plus 2s square minus s minus 2. Now I am going to simplify this term. So I want to simplify this. We should know the concept of partial fractions. Okay, so if I want to do anything, first I have to split this into linear factors. So how I am going to split means, let us check once. So in the first term I am taking s square common, we'll get s plus 2. Here in the second term, if I take minus 1 common, s plus 2 will get, which is equal to 6 divided by s square minus 1 into s plus 2. So which is equal to 6 divided by s square minus 1 can be written as s plus 1 into s minus 1 into s plus 2. So first step I have taken, or I have splitted this given term into several linear parts. Once you splitted this into linear factors, I can write this as a divided by s plus 1, that means first linear factor, plus b divided by second linear factor s minus 1, plus c divided by s plus 2. So I can write this term as like this. Okay, so in the left hand side this will remain same. S cube plus 2s square minus s minus 2. So which is equal to, if I take the LCM, in the denominator we will get the same term, s cube plus 2s square minus s minus 2. Here also 6 divided by s cube plus 2s square minus s minus 2. But in the numerator what happens? A into s minus 1 into s plus 2. Other than this term, I am going to write this. Plus b into, we have to skip this term and write the remaining, s plus 2 into s plus 1. Plus c into s plus 1 into s minus s minus 1. So now these two denominators get cancelled. Now 6 is equal to, we got some expression, a into s minus 1 s plus 2 plus b into s plus 2 into s plus 1 plus c into s plus 1 into s minus 1. Okay, so now what I am going to do is, I am going to substitute some values, that is at s is equal to plus 1. If I substitute s is equal to plus 1, if I substitute s is equal to plus 1, the this term will become 0. So that I'll get the quotient of b term. So let us see. 6 is equal to, now I am going to substitute s is equal to 1. So first term will become 0 plus b into 1 plus 2, 1 plus 1 plus, since we are having s minus 1, 1 minus 1 will become 0. So implies 6 is equal to 2 into 3, that is 6b, which implies b is equal to 1 will get. So now at s is equal to minus 1, let us see what happens. Is equal to a value will get minus 1 minus 1 minus 1 plus 2 plus second term will become 0, third term will become 0, which implies 6 is equal to, will get minus 2 into plus 1. So I'll get minus 2a, where a is equal to, will get minus 3. At s is equal to minus 2, if I substitute, we'll get c value. So first term will become 0 plus second term will become 0. Now third term is minus 2 plus 1 minus 2 minus 1 into c, which implies 6 is equal to minus 2 plus 1, you'll get minus 1, minus 2 minus 1 minus 3. So you'll get minus 1 into minus 3, you'll get plus 3. 3c implies c is equal to 2 you'll get. So we got a value, b value and c value. Now I am going to substitute in this. So 6 divided by s cube plus 2s square minus s minus 2 is equal to, we got minus 3 divided by s plus 1 plus 2 divided by s minus 1 plus, sorry, b value we got it as 1. So that means 1 divided by s minus 1 and 2 divided by s plus 2. So a value is minus 3, b value is 1 and c value is 2. So now I am going to substitute in equation 1. So what is that equation 1? This is your equation 1. So we got y bar of s is equal to this much, minus 3 divided by s plus 1 plus 1 divided by s minus 1 plus 2 divided by s plus 2. Now I am going to apply inverse Laplace transformation for this. So L inverse of y bar of s is equal to L inverse of minus 3 divided by s plus 1 plus L inverse of 1 divided by s minus 1 plus L inverse of 2 divided by s plus 2. So as you know the formula for this, directly you can do. So minus 3 into, the formula for this is e power minus t plus e power t plus 2 into e power minus 2t. So this is the required solution of the given problem. So L inverse of y bar of s can also be written as y of t. So this is the required solution of the given problem.